high pressure, then the pipe work might be a little bit more expensive as well compared to the low or mostly low pressure that we have in our system. So there I've seen that Vortex is more competitive when it comes to the cost of the filter system. But it depends a little bit as well of how many zones are you protecting, how big are the halls, and also very important, don't forget, the water mist system is going to control your fire, and Vortex is going to put it out. So that value is something that you cannot really forget if you're putting this in front of a client. We're going to put out that fire, which is different than, yeah, you might have reignition, you might need to continue adding water, and the equipment that you have there, that's gone. So that's an additional thing to consider. I have a question.
واخد الشبكه لما هندسه ولا
مش عارف، انا ما شفتش لسه مصدر الميه جاي منين وايه بمب ولا
لا مالوش بومب بيعتمد على ضغط الاسطوانات بتاعت النيتروجين.
ايوه الميه منين؟
الميه من
So the water tank itself can be far away, but because we pressurize it already up front, all the water pressure will be up until here. So the real distance that you need to worry about, because there is indeed a limitation within 30 seconds, that water needs to reach the furthest emitter. A little bit similar to a sprinkler system, but then 30 seconds. In that case, you only need to look from the panel here up until the last nozzle. So when it's about limitation, where do I put my cylinders, where do I put my water tank, that can be on a different floor. We're doing a project now in Ireland, and it's in a different building across the street, 150 meters away. Because we have the low pressure on the nitrogen side, we have the advantage that we can run for a very long length without losing a lot of pressure and still be effective into extinguishing and reaching our pressures at the nozzle. No. What are the options that we're offering with the Vortex system? The first is going to be the Vortex 500 system. This is a plug and play that we're also using in our demo units in the different facilities that I mentioned. And you can see the water tank there, this little fella. That's not a lot of volume, that's not a lot of water. So this will also only be used in Class A, Class C type of fires, so ordinary combustibles and energized fires. This will not be for your Class B. If you have a turbine, if you have a generator, you generally will have a much higher fire load. You're dealing with heptane, diesel, lube oils, so that will have a higher fire load, that will require more water. In our design, we're going to add more water there, a little bit less gas. If you're designing for an electrical room, control room, any sort of electrical equipment, you want to have less water and a little bit more gas, just to eliminate the amount of water that we're actually using in this system. And in that case, this is a 4-cylinder unit. It can be installed up to a volume of 130 cubic meters, so not the largest amount, but we of course have installations that go bigger. But the good thing about this Vortex 500 is that it's a plug and play. Even better than the panel alone, it is completely plug and play. So it goes with the cabin, all the pipe work is already there, and you can immediately place it in the room. 1 day, maybe 2 days of installation with detection, and you're gone, you're out. But then the limitation of volume is 130 cubic meters. All right?
Excuse me.
Yes.
Extinguishing duration for this system, how many minutes?
The activation of the system?
Yes, for how many minutes?
The activation will depend a little bit on the detection.
No, I'm talking about you decide a certain water tank, right?
Yeah.
Your system will work to extinguish the fire for how many minutes?
3 minutes discharge in total.
How much?
3 minutes in total.
Only 3 minutes?
Yes.
The approval is for 3 minutes only?
Correct.
For
Because you're adding the gas as well.
For a certain hazard?
For data processing equipment and Class B.
What about fire ignition, reignition? Did you consider?
Of course, the gas will be there. Similar to an energen system, you have your retention time. You have your 10 minutes retention time where your oxygen concentration is on a level where a fire can't reignite anymore. It's not only the water that's doing its job, it's also the gas.
So total of that duration, you consider your tank size?
Yes.
Okay.
Correct. the amount of water is depending on how long you're discharging, and the standard and the approval is for 3 minutes. So during those 3 minutes, you add the water. Okay? This particular unit can be standing inside of the area of protection or a room adjacent to it. And then you can turn those emitters around for 180 degrees and have them inside of the room. This is coming to your point as well, sir, where you have the manual activation board. Here, if you have the unit standing inside of the room, you can have a manual activation at the door or something so that you don't have to go in. If there's a fire, nobody wants to do that, but you can either manually activate it so that it goes. And when we're having larger applications, larger volumes, we could go to these type of systems. The principle always is the same thing. You have your nitrogen, you have your water tank, you have your pipe work to the panel, and from your panel you have your pipe work to the emitters. If you're doing multiple zones, this is an example here we did in Frankfurt, where we had multiple zones. Basically what we did is the data halls that we were protecting were, I think, 2 times the size of this room here, about 4,000 cubic meters. And the amount of cylinders that we needed are also, it's only the one system. And because you have the low pressure line, this was protecting 150 meter of a building, 50 meter wide, and 2 floors up. Electrical rooms, battery rooms, data halls, switchgear rooms, low voltage was also protected by this single installation. What you can also see here that there's a refill point. That brings me back to the question that you had on refilling. So what we did there, the insurance company, because Vortex was relatively new, they wanted to see a full discharge. Not only that, they wanted to see a full discharge on live 20 kilovolt battery room. Now this was the first installation that I did in Europe. To be honest, I was a little bit afraid. Just because 20 kilovolt is not to joke about, and also it's the worst case situation for us, because there's no fire. If there is a fire, the heat of the fire will form the water into steam, and steam is also not conductive. So the big question I have personally, what is the system or what is the water going to do on live 20 kilovolt equipment? We did a full discharge, 7 cylinders went in, there was indeed water, but there were no damages on the equipment itself. Insurance, the end owner was very happy. Now, why do I tell this story? Because the next day, naturally, we had 7 cylinders that were completely empty. Normally, we need to go back to the shop, fill them, bring them back, and that's all the time that it costs, installation. And what we did here is we had a refill point, where we just opened up the refill point, we connected to 300 bar cylinders, and we cascaded the nitrogen inside of the empty 7 cylinders. We never moved or touched any of the bottles that were there. The next day, because we knew that that discharge was going to happen, the next day the system was live again. So that was within the 24 hours requirement, showing that it is possible to do if you do the homework to do so. Yep. A couple of videos, this is always interesting to see or to show, and then I'm going to be at the end of my presentation, so you can have a break. The first video is local application test that we did. So not only on total flooding, but we got a question from a steel mill company. What can you do on local application? I want to protect a very large line and a very big building, but I don't want to protect my full building because the volume of my building is huge. So if I want to fill with nitrogen all of it, I'm going to be out of money because it's going to be very expensive and the footprint of the nitrogen will be ridiculous. We agreed and we said, okay, we're going to do some testing with you. And this was done at an FM Global facility in Denmark. We have a 2-meter heptate fan at the bottom, so 2 meter by 2 meter. There's 4 emitters or nozzles at the top, and we're going to use the principle of the speed of the nitrogen and the cooling effect of the water to extinguish the fire. It's not really total flooding because the volume is much larger than what we require, but we're just going to look at that local application. Now what you see there as well, at the right-hand side, there's a flame burning at the right-hand side. That is representing a person standing close to that area. There's one gas that has local application approval, and that is CO2. We all know it from like fire extinguishers. CO2 is very good at putting out fires. Unfortunately, it's also very good at putting out people. It's not very healthy for us. to have a very large amount of CO2 in their body. So to represent the person that is standing close to the fire, but that cannot go out, that is that fire over there. The reason why I say it, at the end of the video, that fire will still be ongoing. And I don't want to hear the question, why are you not successful in putting out that fire? That was the point. So because you're representing a person there, you cannot put out the fire according to the standard. All right? And on top of that, we also have, you might see it a little bit in the shadow, a diesel spray. So there's going to be a certain point during the activation that diesel will be actively spraying on top of the live fire. What is this simulating? A generator, a turbine, any sort of machine that has a broken fuel connection. The fuel is gathering on the floor, and you don't have an ignition yet. There's not yet a fire, but there's active fuel just spraying under pressure. At a certain point, you might have an ignition, and everything goes. And on top of that, you're just spraying additional fuel on it. So this is a typical FM test that we do. The amount or the energy of the fire is a 6 megawatt diesel spray fire. My colleague will say it as well, but he's wearing like a muzzle due to fire protection, so you might not understand.
This is a 6 megawatt diesel spray with the external ignition source. 1 emitter, so 10 to 12 psi around.
If you look closely at the top, you might see one of those emitters. There's 4 in total. For every square meter at the bottom, we have 1. It's a little bit different design than total flooding. But NFPA 770 also allows for total flooding. That's our local application. We're going to count down in a couple of seconds. And right now, the system has not started yet. Even the diesel spray has not started yet. But soon that diesel will be there. 3, 2, 1, go! That is your diesel, and the system will start in about 10-15 seconds. Total time of extinguishment was 25 seconds. So, and as I said, the small flame there, the person standing close to it is not extinguished because he's outside of the area of local protection. So within that short time frame, we were very effective because you're using both the effect of locally putting down the oxygen concentration and also cooling the core of the fire where it matters the most. That's how you get an efficient extinguishment. The next video was something that we got from our competitors, really. Our competitors had the question because room integrity for them is a big issue. It is their biggest cost that they have in the system in the sense of maintaining. But they also had the question, okay, if you have a permanent opening and you have a fire right in front of it, what is going to happen? You have oxygen right there. Isn't that oxygen going to reignite? Isn't it going to enlarge the fire that you have ongoing? Or just put it on. So for that reason, we did the following test in our own testing facility with UL and FM watching. We had a complete discharge that was done. We opened the door at a 30-degree angle, so you have a fairly large permanent opening. And then somebody is going to walk in with a propane torch. So from the left side, he's going to come in, and you will see what happens once he enters. So basically, the second that he walks in, you have an active wall of fire protection that will prevent any sort of fire. That vortex effect will have or create that wall. Now he does that test again, a little bit slower this time, just to prove that the propane torch wasn't empty the second that he walked in. And this time it was about 10-15 centimeters from your door that you have your active fire protection. All right. That brings me to applications and references. As I already said, globally we have about 1,000 systems installed. This will increase much more now that we're going to have that inoperable of the system. Most of our installations are going to be 60% of them in crucial electrical equipment. Data processing equipment, control rooms, switchgear rooms, MV rooms, LV rooms are all a possibility. And then 40% of the other installations are going to be in generators, turbines, machinery spaces. In the automotive industry, we also have a couple of references. And even in museums, libraries, we've done it in storage rooms of museums. That's all a possibility. The big thing to think about is, what am I protecting? Again, equipment protection rather than building protection. Usually, the stuff that is inside of the room is more important than the building itself. That's the way that I see it when I'm looking at applications. Hospitals, MRI rooms. MRI rooms is the big plus. Why? We can use that plastic emitter. You cannot have any ferrous material in a hospital. An MRI will just, it's a magnet, it's a big magnet. So any sort of ferrous material, it will just suck there. Because we can use plastic material both on the pipe side and on the nozzle, you can install it in hospitals. So it's a very good application. That brings me to the conclusion, and then you can have a little drink, a coffee, something to eat. The strong points that we have with the Vortex system or a hybrid system. The first one is going to be your room integrity. I mentioned it multiple times throughout this presentation. When you compare it to a gas system, we do not require to have a completely sealed room. Because of that, you do not need to install pressure relief dampers. Because of that, you're saving a lot of maintenance costs, and you don't have to worry if another contractor comes in that isn't a fire contractor, am I still going to have a safe system? Because at the end of the day, if something happens and a fire breaks out and the gas system does not work, who are they going to contact? Not the contractor that made that permanent opening, but the contractor that installed the system. So that's something that you can always think about, and the Vortex system takes that all the way. Now, on the refill cost, it's a very low refill. It's just nitrogen. It's not Victaulic patented nitrogen. So any type of nitrogen, any local supplier that you can have can refill it when they are capable of doing 200 bar. So the nitrogen itself, industrial gas used everywhere, it's very cheap to refill. What we noticed, what I noticed like in Europe, is that the highest cost is the transportation because it's high pressure vessels. The cost of the nitrogen is peanuts compared to the transportation of having the solution. The next point is the low water requirement. Yes, we are using water. Yes, we are using it in electrical rooms, but the amount that we're using is peanuts. The size of the droplets is so small that you don't see conductivity. Again, feel free to come over to Dubai, to Belgium, to the US, to see it with your own eyes. And that's the same equipment. I've been using the laptop for 10 years now. It's still the same laptop. It still works perfectly fine. When it comes to the flexible design of the system, because you have that low pressure, you can have a very long run of having a load system. The Vortex can be ideal because the amount of water can be just in a small water tank. You don't need to have a big storage tank of water somewhere. Finally, or almost finally, there's not going to be any equipment damage. Why is she here? Well, because she looks prettier than a server room or a generator room. But again, it's the point that it's valuable equipment. It's whatever that is inside of the room that has value that we're protecting. And last but not least, it is a green system. Natural resources only. Nitrogen, water. We're not going to have any byproducts. We're not going to have any effect on global warming, not on ozone depletion. So this fits in a lot of things that are going on in fire protection when it comes to environmentally and sustainability. Okay? Due to COVID, I have my business card in my presentation because I have done this presentation for a long time from my seat at home. That's why it is here. If you are interested, either myself or my colleagues, we can send you this complete presentation. It includes the videos, it includes all the information that I've been talking about.